Hello everyone. Today I'm going to tell you about the significant role of transition metals copper and zinc in the development and treatment of amyotrophic lateral sclerosis. I'm going to be talking a little bit about what exactly amyotrophic lateral sclerosis, abbreviated ALS, exactly is. I'm going to tell you about the predictive relationship between ALS and copper and zinc because of the ALS gene. I'm going to tell you about an experiment where copper and zinc levels were looked at in ALS mice. And we're going to look at how these two metals, copper and zinc, could potentially be a therapy for the disease. I'm going to tell you about a potential therapy that is in the works and talk about my personal critiques regarding general ALS research. And we're going to take a look at some interesting statistics. So amyotrophic lateral sclerosis, abbreviated ALS, also known as Lou Gehrig's disease, is a neurodegenerative disease that affects the central nervous system. It's an always fatal, quickly destructive disease. Around 1 in 100,000 people are estimated to get it per year. This is kind of a visual representation of kind of what ALS looks like to a lot of people. Stephen Hawking is one of the most famous ALS patients. However, he had a really amazing quality of life compared to most ALS patients. There's two main classifications of ALS: limb and bulbar onset. Bulbar really affects from here up. First, it affects breathing, speaking, eating, a lot of saliva, a lot of salivating. Limb onset affects motor skills more. Patients trip, fall, can't hold stuff. That's what they notice first with symptoms. Either way, whatever classification, limb or bulbar onset, patients usually succumb to the disease 2 to 5 years after initial onset of symptoms. So ALS patients succumb to the disease from respiratory failure. Their diaphragm shuts down from muscle degeneration, neuron degeneration. However, there's really no brain damage, which is interesting. Their patients are usually completely conscious of their physical states. It's like they're prisoners to their own body. Currently, there's no cure for the disease because underlying mechanisms are really unknown. This makes it hard to develop a drug if you don't really know what the problem is. So researchers have kind of turned to looking at the genetic properties of the disease. There's two main types of onset of the disease. It's called familial ALS, which is 10% of cases linked to family genetics, and then there's sporadic ALS, the rest of the cases, which are just kind of unknown causes. However, in both familial and sporadic cases, researchers found a gene in 1993 commonly mutated in both types. This gene was called copper zinc superoxide dismutase, and it has been the focus of multiple studies in the past 20 years. So this gene, copper zinc superoxide dismutase, pictured below, is a homodimer. It consists of a structural zinc ion pictured in blue on the outskirts and a copper ion in the middle in the orange. Considering the structure, researchers have tried to find a link between ALS and copper and zinc itself. They've anticipated a really strong link, and as a chemist, I have been really interested in that, and that has been the focus of my research. So it's predicted that copper zinc superoxide dismutase mutates by copper-mediated oxidative stress. On the right is what it is supposed to do. It's supposed to take oxygen radicals, reduce them down to hydrogen peroxide. However, if there is a problem and this doesn't work right, then this can cause structural changes in the gene. And this will result in a decreased binding affinity for copper, a decreased binding affinity for zinc, and an increased binding affinity for copper. And this is what is suspected to cause neuronal death, seen on this picture below in ALS patients. And so to test this hypothesis, I found a study that was conducted in 2018. It tried to detect the metal levels of copper and zinc in ALS model mice. They were detected in the cerebellum and the spinal cord. So to the ALS mice had the mutated SOD1 gene, and there were wild-type mice. So at either 8 weeks or 16 weeks, these mice were euthanized, and the spinal cord and cerebellum were dissected and analyzed. If we consider the binding affinities that we talked about in the previous slide, it was expected the mutant ALS mice would contain an elevated amount of copper and a decreased amount of zinc. So to determine these copper and zinc levels, the spinal cord and cerebellum samples were digested in nitric acid and placed in boiling water, diluted with ultra-pure water. ICP-MS, inductively coupled plasma mass spectrometry, was used to determine the concentration of copper and zinc in the tissues, and this was reported in micrograms per gram of wet tissue weight. This kind of gives you a brief overview of ICP-MS, just to kind of jog your mind of what that is there. So the SOD1 ALS mice did reveal a significantly abnormal levels of copper and zinc. 8 weeks on the left, we can see the copper levels were increased and zinc levels were significantly decreased. 16 weeks, you can see a much bigger difference in copper levels and an even bigger difference in zinc levels. I think it's really interesting to even note there's changes at 8 weeks in the levels. This is really young. The experiment also tested motor function. There was a significant decrease in motor function after just 12 weeks. This just shows the rapid onset of the disease. And even at 8 weeks, when there was no motor function, we saw on the previous slide that there was copper and zinc imbalance. So this kind of suggests that copper and zinc could play a role in the early onset of the disease. So will there ever really be a cure for the disease? Like, is that going to be a thing? There's only 3 approved drugs currently even on the market. They're called Radicava, Ryotech, and Nuedexta. They're not any sort of cure drugs, and they only improve conditions in some patients if they're lucky. In my opinion, researchers really need to be studying this link between copper and zinc, because research has proved that there is some link between this. So it's essential at this time to further explore this link. I did try to see if there was any research in the making of copper and zinc drugs, and there actually was a development of a copper drug. It's called Copper ATSM. It's allowed to selectively transport copper in and out of cells. This was in the making 2018, and I did find research conducted at Oregon State University in 2019. It showed that this copper ATSM essentially stopped ALS progression in mouse model for 2 years, which is pretty amazing. But obviously, there hasn't been a lot of research done on human test subjects, so we can't, it's not FDA approved or anything like that. There's a little table on the right here I put together showing kind of the different drugs that we have on the market and some that are in the works. There's a few more in the works. I think it's really interesting to observe that all these drug effects are really, really different. This kind of shows that researchers have no idea like where they're going with the treatment or even the underlying mechanism. So it's really time to treat this like cancer or something else. And we need to put more money into funding and figuring out what the heck is going on with this disease. So in my opinion, ALS research needs to be improved a lot for a lot of reasons. I found it really hard to find any research with human test subjects, which I found very surprising because I know plenty of ALS patients and families of ALS patients that would be willing to be a part of a trial or even donate their body to science after death. I did try to find a study conducted with human test subjects related to the copper and zinc imbalance that I have been researching. And I did find a study in 2018 with 31 living ALS patients. And it was found that they did have a significantly higher copper isotope composition in cerebrospinal fluid. Zinc wasn't found to be hugely imbalanced, but just further suggests that copper plays a role. So I think it's really important to perform more trials like this, more trials with human test subjects, because there's plenty that are willing. So something really interesting to consider is ALS is predicted to really dramatically increase in the future. The population is expected to age significantly in the future. This disease is not just fatal to the patient, but it's really kind of fatal to the family because it causes a whole lot of financial stress. There's a whole lot of needed medical equipment. It often results in bankruptcy for the family. So it's a huge economical problem. So there's many reasons as to why research should focus on finding a cure for ALS right now. So there was a study conducted in 2015. ALS is actually expected to increase by 69% from 2015 to 2040. This is likely an overestimate due to improving healthcare conditions. Like I said, this is predominantly due to aging of the population. ALS most commonly strikes adults, 40 to 70. So as the population increases, there's going to be more neurodegenerative diseases. Like I said, this is an overestimate, but these are really significant results, and they should be used to inform healthcare workers, university. More research time needs to put into understanding the mechanisms and focusing on a treatment for ALS. So, like I said, it's been hard to develop a treatment because underlying mechanisms are really unknown. But there's lots of research proving copper and zinc does play a role. So my whole take-home message right here is that we should focus on these metals, transition metals, copper and zinc, heavily in ALS treatment and research. I've had some really heavy motivation for this topic. My mom was diagnosed with ALS less than a year ago. She has bulbar onset ALS, and today she can no longer do anything on her own. So this research has been really important to me and really interesting to me. If you want to do anything to help, there is an ALS association. They take donations. You can reach out to me if there's anything you want to do to help. But these are just some fast facts to take away with you. I mean, just keep this in the back of your mind. There's a lot of diseases out there, but this one, it hits home for a lot of people. And just keep ALS patients in the back of your mind. And as medical professionals and chemists, we should take the time to think about it more and think about cures for it more. I appreciate you guys taking the time to listen to me, and I hope you enjoyed. Thank you.